Hello guys, welcome to this part of the RC analysis. This is San here. Now I will be discussing this question in which we have to find the output waveform. Given Vn is a pulse input of amplitude 5 volts and time period t, and we do have two cases here. The case one being t is much greater than RC, and case 2 being t is much smaller than RC. So now we'll try to find the output waveform for the case 1. So here if t is much greater than RC is lower, right? Which means time constant of the circuit is very low, which implies the charging and discharging of the circuit, charging and discharging will happen faster, right? So the capacitance has enough time so that it can charge to the complete value and discharge completely to zero. Okay, so here this is a simple low pass filter. We have already discussed what happens to the output waveform when the input is a step input. We'll use that output to solve this question. Okay, so if you see here, this is a enlarged version of the given input signal. Okay, at t is equal to 0, there is no input given to the circuit till t by 2. So the output stays at 0 until it reaches t by 2. At t by 2, the input becomes 5 volts, right? So the capacitance charges till it reaches 5 volts, and till it reaches t, the output stays at 5 volts, and at capital T, the input becomes 0. So the capacitance discharges through the resistance and it becomes 0. The voltage across the capacitance becomes 0. It stays there till it reaches 3 by 2 T. Okay, and this cycle continues. So again it charges to 5 volts, stays there, and again becomes 0. Okay, this cycle continues. Okay, now for case 2, we have RC much greater than time period, which means the time constant is high. So what does that imply is that the charging and discharging of the circuit will be slower, right? Be slow. So the capacitance does not have enough time to completely charge or completely discharge. So it charges to some intermediate value and discharges to some intermediate value. Okay, now we will try to plot the output waveform here. From 0 to t by 2, the output remains at 0, and from t by 2 to t, the input tries to charge the capacitance, but it just charges to some intermediate value. Say this is 1 volts and this here is 5 volts amplitude. Okay, now as the input becomes 0 at t is equal to capital T, it tries to discharges to some intermediate value. Say it discharges to 0.7 volts. Okay, and again it charges to value, say 1.2 1.3 here. Okay, and again it discharges to some value, say 0.9 volts. Okay, if you look at this trend of the charging and discharging, initially the rate of charging is greater than rate of discharging, right? Why is it so? Because if you see here, initially at the time instance between t by 2 to t, the capacitance charges with the value being 5 by R and discharges with the value being 1 by R. And in the second cycle, the The rate at which the charging happens is with 4.3 divided by R, and rate at which the discharging happens is 1 by 3 divided by R. So initially the rate of charging is higher, rate of discharging is lower, and as time goes on the charging rate decreases and the discharging rate increases, and at some point the rate of charging and discharging becomes equal, right? Rate of charging and discharging becomes equal, and that point is exactly V in divided by 2 volts, which is 2.5 volts here, and this happens at time around 5 tau. Okay, so this is the point where the oscillation of charging and discharging revolves around a constant value, which is 2.5 volts. This is very important thing to remember. They might ask you in the interview as well. Okay, so keep this thing in your mind. Thank you for watching this video. I'll meet you guys in another video.